Hello and welcome to 12.4. We are now working with volume. Now we just finished up surface area and volume is our next step, and we are now working in three-dimensional space and three-dimensional units. So volume allows us to work in the actual physical space of 3 dimensions. It is the representation of space. It is representation of space in 3D, or I should say a 3D solid. There you go. A 3D solid occupies. So what that means is it's just what space. We usually have area. It's length times width, and now we have a vertical height that adds to the actual units in which we are trying to count or measure. And we represent this in cubic units. So we have cubic units. So measured in cubic units, meaning we'll have units cubed instead of squared. Let me write that better. Units cubed, feet cubed, inches cubed, etc., etc. Okay? And volume of a prism. The most important thing to anything that's volume is actually the base. Okay? Even if it's a cylinder, the base is the most important piece because we need to actually calculate the area. As we know, volume has always been, or hopefully we know, volume is measured as length times width times height, but that's only if it's a rectangular prism. If we want to generalize it to any shape, we think about this in terms of bases. So volume of a prism, let's keep this simple, of a prism first, something we already know, hopefully know. We want to identify the base. Okay? And it's important to have a top base and a bottom base so that, and they're congruent to make this as easy as possible. So we're going to say that this equation is equal to area of the base times the height. What this actually does is this. I'm going to draw this in pink so you don't have to copy this down, but just conceptually, as we know, area is equal to length times width times height. Okay, well, let me redraw this. Let's draw the top first as I've done in the past. Draw these down. And volume would be length times width times height. But as we know, that only works in a rectangular prism. So what we want to do, ideally, is to calculate the base and then multiply it by the height. Okay? And that makes this significantly easier to generalize across multiple prisms, in cylinders even. So let's do it. We have an area that's always measured. Let's do this. Area is always measured in units squared, and that's getting multiplied with a height that's a unit by itself, which makes our units cubed. Okay? And in this case, let's do a quick example. Example 1. Let's take a square prism. Now, square prism just means that the base is square. It does not mean it is a cube. It means the base is square. Okay? So I'm going to put that in here. The base is square. It is not necessarily a cube. A cube would mean all sides are congruent, or length, width, and height are all congruent. So square prism, let's draw one out. Let's draw the top. Let's draw the height of it. The height is clearly different, and ideally this is pretty much what I drew in pink. And then let's draw the sides that you cannot necessarily see. Okay, so now we have a height. and we have a height that is not the same as the sides of the square. So let's say that this is 5 and the height is 12. Well, that means all sides on the base are 5 on both the top base and the bottom base. Okay? And we could actually do this, right? Area of the base. Volume, I should say. Volume is equal to area base times height. We know the area of the base is equal to 5 times 5, which is 25. We know the height is 12, so we do 25 times 12, and that should be equal to 300. So the volume here is equal to 300, and I don't have a unit of measurement, so we say units cubed. We are done. Okay. Now, a cylinder is very, very similar. So let's say the volume of a cylinder, of cylinders. So it takes the exact same concept, and we're going to say area of the base times the height. It's the exact same concept, equation, okay? Area of the base times the height here. Let's highlight that. And here. The difference, though, is the base. Okay, the base is a circle, right? And if we were to find the area of a circle, we need the radius. So we need to do pi r squared. So we have pi r squared for the area of a circle because it has a circular base. Okay, the height stays the same, it doesn't change, and we could draw our cylinder. Now we have our cylinder. Now let's pretend, let's do a little bit of some dimensions here. Let's say we have this line here, and let's say that line, the diameter, is equal to 6. Let's say meters, okay? Let's also make this a little more interesting and say that this line from the bottom of the cylinder to the top corner of the cylinder, excuse me, is equal to 5. Can we solve for the height? Well, absolutely, we could. This is our height. We don't know what it is, but we actually create a right triangle here. Excuse me. Now, I did not mean to put a 6 here. Sorry, I meant to put a 3. Excuse me. So we have a right triangle here with a leg that's 3, a height we don't know, and a hypotenuse that is 5. And we should have a 3, 4, 5 right triangle. So that means our height is 4. And now we could solve. If this is a length of 3, a diameter of 3, that means a radius is equal to 1.5. And now we can actually solve for the area of the base. Area of the base is then pi times 1.5 squared. 1.5 squared is 2.25 pi. Multiply that with the height that we just solved for is 4. And we get a volume of, that's approximately, that's exactly 9 pi. This is measured in meters, so meters cubed. And we are done. Okay? So, if you want to rewrite this equation as pi r squared times the height, you're more than welcome to. I personally would just keep this as our general understanding, area of the base times the height, to solve for the volume of any prism or cylinder. All right, if you have any questions, please bring them to class, and I will see you in the next one. Bye.